When we're working with expanding binomials, there are some cases that are convenient if we can recognize them quickly, save us some work in doing calculations. Those are working with perfect square trinomials and working with difference of squares. And when we start undoing all these operations, it will make them a little bit quicker for you as well. So in terms of perfect square trinomials, which we'll start with here, let's just expand and simplify these. So if we expand these out, x plus 4 squared, so that's x plus 4 times x plus 4. It's going to get me x squared plus 4x plus 4x plus 16, which is x squared plus 8x plus 16. Let's try the next one here. X plus 3 times x plus 3, or x squared plus 3x plus 3x plus 9, which is x squared plus 6x plus 9. So if we look at these first two, we're just rewriting the equation out, but then it's 4x in the middle, those two terms together, 4x, they add up to 8. So double the 4. So double the coefficient here. And then 16 at the end. That's 4 squared. Here, the coefficient is 3. So double 3. And then 3 squared. So this next one should work out to x squared, double the 5, which is 10x, and then 5 squared, which is 25. Let's test that out. X plus 5 times x plus 5. And we get x squared plus 5x plus 5x plus 25. And it does work out. So all we're doing here, in the case of adding perfect square trinomials, is it's a squared and b squared at the end, both positive, and then 2 times a times b, whatever values are at a and b. In the negative situations, let's try one out, see what differences we get. X minus 4, x minus 4. So that is x squared minus 4x plus 16. And we get x squared minus 8x plus 16. So the difference here is that the middle term is going to be negative. So this next one would be the same as above, except the middle term would be negative. X squared minus 6x plus 9. And the last one, x squared minus 10x plus 25. So in general, with a negative sign, the middle term is negative, otherwise it's the same. Now note, all these examples just worked with a whole number, or sorry, a 1 in front of the x. And so let's just quickly check one more here. We'll call it f. Actually, that was f. I don't know why I put a d again. Let's call it g. And we'll do 3x minus 4 squared. So if we follow our rules here, it's a squared. So we take our a term, which is 3x. 3 squared is 9. X squared is x squared. And then it's negative 2 times ab. Well, a is 3x times negative 4. That's going to be negative 12x times 2 is going to be negative 24x. So that's 3 times negative 4 times 2, and then the x. And then finally the b part squared, which is the negative 4 squared, or 16. So if there's a number out front here, it is multiplied in that a and b section, or first and middle term. Now the other situation that is pretty convenient to recognize and probably even more so used, you'll see this a little more often, I think, is the difference of squares. So difference of squares, let's start expanding a couple of these and see what happens. We got x plus 1, x minus 1. So this is x squared minus x plus x minus 1. Those two there will add to 0, so I'm just left with x squared minus 1. If I do the next one, I get x squared minus 2x. If I FOIL this out, plus 2x, and then minus 4. Again, those middle two terms will cancel, and I'm just left with x squared minus 4. This is the first term squared. That's the second term squared. And there's a minus sign in between. Happens both times. 1 squared is 1. So over here, I should get x squared minus 9. Let's double check it. X times x. And then I got x times positive 3. Negative 3 times x. Negative 3 times 3. Should be an x there. And then a minus 9. And there we go. With negative 3, positive 3, those cancel out. And we're left with the x squared minus 9. So that's it in general. If we have a squared, or a plus b times a minus b, then it's the first term squared minus the second term squared. Even if we bump up the numbers here, make it a little bit more challenging, it's the first term squared. 2 squared is 4, x squared is x. Minus sign, second term squared, 16. Even when there's a variable on both sides, 3x plus or minus 5y, 3x plus 5y. Well, square the first term. 3x squared is 9x squared. And then negative 5y here. So the minus sign, 5y squared is 25y squared. That's it for solving these ones. You'll see the difference of squares more. Those are the ones that you want to make sure you do understand. Perfect square trinomials, we'll use them a bit in one of our later sections, but not quite as vital as making sure you really understand your difference of squares. These ones pop up all the time. It'll make your life a heck of a lot easier if you know how to do them without much thought.